I have just gathered some information pertaining to all these buzzwords that we are today coming across pertaining to data science. So I'll start with my presentation. Okay.
Please, ma'am.
So very good morning to all of you. And I'll just switch off my video if you allow me so that. Okay. So starting with my talk on demystifying data science, we all know data science is a buzzword, and as per Forbes information, this is the most glamorous data scientist job is the most glamorous job of the 21st century. And we along with data science, we get to hear many other buzzwords like business analytics, business intelligence, data analytics, data mining, data warehousing. Then you have big data, talking about then data analytics, and then also you have this what you call data warehousing. I've already talked about. So all these buzzwords, machine learning, deep learning, cloud computing, and then IoT. So all these terms have come in, these words have come in. And now this new thing, data science, this has not come into existence now. It was there long back also. So I'll be talking about a little bit about everything. See, my first slide shows you, I put on some pictures of some files, then Facebook, Twitter. Then you have this, what you say, the stock market picture is there in front of you. Then you see an aeroplane. And this probably, if anybody can guess, what is this? Anybody? And this is obviously the satellite. So this picture is of the Large Hadron Collider. So all these pictures, the purpose of putting these pictures is that they are generating what? The data for us. And you all know the facts and figures. We have almost created, every second we are creating 1.7 MB of data. Every second by each individual. This is the survey of 2020. That 1.7 MB of data is created every second by every person. And in the last 2 years itself, 90% of the world's data has been created. So initially we had less data. 90% of the entire data has been created in the past 2 years only. And then what? 463 exabytes of data will be generated each day by humans by the end of, they say, 2025. And by 2020, they say 44 zettabytes will make up the entire digital universe. And, every day we have around 306 billion emails sent, 5 million tweets are being made. And then Google processes around 3.5 billion search queries every day. So, and that is why Google is the king. And they say it is, that's a fact. Google is king now. It's popular enough to turn the company's name into a verb now. They don't say, let me go and go to the internet and look for things. They say, let me Google that. Yes? You all agree to that or not? And then, every day we are generating 350 million photographs are being uploaded to Facebook each day. And then talked about tweets and emails. So this is data. Even a plane that flies, picture being depicted here is generating data for you. Then stock exchange every day, millions of data. And this is the Large Hadron Collider I told you. And this is what? This is a particle accelerator. And this is there in CERN, which is a European organization for nuclear research. And this is also generating data, Facebook, Twitter, satellite data. So what do we do? What do we do? So data is big, lots of data, lots of analysis, and lots of jobs which are being created. And I told you this is going to be as per Forbes, this is going to be the sexiest job, data scientist job, or it is the most glamorous job. So everything around you collects, generates data. Social media sites, be it your business transactions, your location-based data, your sensor data, your digital photographs that I talked about, your videos, your consumer behavior, the behavior online, you go and purchase. So your behavior is being captured. Okay. So all these and more of data is publicly available. The data is available with you. Data technology is advancing, cloud-based and mobile applications are widespread. So what do? Far too many companies, they have good information with them and they do nothing with it. And this is truly amazing, participants, because the data is nothing but it is a gold mine of insight. Okay, what is it? It is a gold mine of insights. By insight, I mean you can mine that and generate, increase your customer loyalty. You can unlock hidden profitability, or you can reduce the client churn. And then when you're sitting on the data, loads of data, and you aren't using it, then that is very wrong. The idea is to make the best use of the data that you have. Don't just sit on the data. And the data I told you is of varied, versatile forms. The data is of versatile forms and structures. And they have a different semantic meanings also. And then you have, you must have heard of time related or sequence data, which talks about our historical records, your stock exchange, your time series, or your biological sequence data. And then you have your spatial data, wherein you talk about your maps and all. Then you have your engineering design data, that is the design of buildings, system components, or some integrated circuits. Okay. And then you have your hypertext or multimedia data. Then in that you have text, images, text, you have images, you have videos, you have audios, and then you have graph and network data also. You also have your web data, which is very huge, which is widely distributed, a widely distributed information repository, which is available on the internet. So all these kinds of data and the applications of these data, they pose challenges. That how do you handle that data carrying special structures? उसमें structures हैं, like sequences are there. You have trees, you have graphs, you have networks, and then they have specific semantics also. Like semantics like ordering, image, audio, video, context, and connectivity. Sorry. And how do you mine those, or how do you get the information from these patterns that carry rich structures and semantics? So that is the idea. Now, if I have data, I will know, everyone wants better predictability, forecasting, customer satisfaction, market differentiation, then prevention and greater use, and all those. See, you have data, you need to utilize that data. And then the things that come to your mind is, how can I price a particular product? What can I recommend online customers to buy after buying X, Y, and Z? This is like the recommendation engines do that. And the surveys or the online analysis that you come out with will tell you how can I price a particular product. How can we discover market segments, group customers into market segments? What customers will buy in the upcoming holiday season? What is the price point for customer retention or subscription? So this we will be able to do when we have data with us, and when we just don't sit on the data. We do some kind of analysis, some kind of mining on that, some kind of machine learning we do on that, so that we are able to make certain future predictions, future analysis. Okay, so these are the things I've listed. So what you do is you also see basket analysis, you must have heard of. This basket analysis, which is also called your affinity analysis. And you look for the items that a customer bought. Customer ने कौन सी चीजें पहले खरीदी, which could help any stores to improve their layouts on, or online companies like जैसे Amazon है, recommend related products. So this basket is what this refers to, what shoppers use when they are shopping, and it is generally based on the assumption that you can predict future customer behavior by the past performances. like including purchases, their preferences. And this is not just related to grocery, it could be related to anything. Okay. So similarly, you are evaluating the use of credit cards. You mine credit card data to find patterns. Our credit card data, the people hold in banks and all, what you do is you mine that credit card data and you generate certain patterns and find and suggest frauds. Okay. And there may be some unusual patterns or unusual behavior in the records that you hold. And then you can always bring out those outliers or undesired behavior or some variance in the data patterns. And then you can analyze those. And then similarly, there are so many examples. You can identify for fraud insurance claims also, by doing all this. Insurance companies can spot claims with high percentage of recovering money lost through fraud, and then develop rules to help them flag future fraudulent such claims. And then you can be evaluating patterns of telephone use. Then you can have your database marketing. Database marketing I've explained here only. By examining the customers' purchasing patterns and looking at the demographics and psychographics of the customers, you to build profiles, you can create products that will sell themselves. Okay, so you can also have sales forecasting and all that. So now coming to see, I got this Venn diagram which could best depict the areas which touch upon data science, though this is not just limited to this, but hope this defines the purpose. Visually linking AI, machine learning, deep learning, data mining, big data, data science. So see here, we can very well, the picture depicts that you have artificial intelligence, the thing in since the very long, the past. So AI has been here since very long. It's not a new thing. And then AI, then we had AI, then we had machine learning come in, and then now we hear the term which is deep learning. And then these are the two terms which are sort of related to each other, not exactly. Data science is usually on all kinds of data that may be structured, unstructured, it could be semi-structured. And data mining, so far we have been seeing it only on the structured data or more of the kind of structured data. So now I'll be discussing all this, and this is big data. Usually, big data, I think the term is not new to you. What is big data? The big data term, I don't think it is new. Big data is, when we talk about the data velocity, the data volume, data variety, and the data in the form of structured or unstructured or semi-structured. By what I mean by structured, semi-structured, you all know. When I say structured documents, then I'm talking about certain databases, the data which is in the form of certain tables, which is organized data. And when I say about when I say semi-structured data, then it could be your emails, it could be your web pages, when talking about your semi-structured data. And when talking about your unstructured data, then it could be your audio, video, your image data, your natural languages, your other documents that you simply write. Okay, so that is what is your unstructured data. So all this comprise of big data. And then since the data I'm talking about has gone voluminous, to handle this, initially we had artificial intelligence, and artificial intelligence is nothing but artificial intelligence is it is the simulation of human intelligence. It is the simulation of human intelligence processes by machines, and especially by the computer systems. And these processes include what? They include some kind of reasoning and self-correction. So some of the applications of AI you must have seen in your BTech level students, like the expert systems, the speech recognition, the machine vision. So these all are the applications of AI. And so this is trying to put some kind of intelligence, making the machines intelligent. And artificial intelligence is like advancing day by day, and it is transforming the world like never before. It is transforming it like socially, economically, and then politically. तो अब जैसे वो देखते हो, you must have watched that movie Terminator. Just to mention of that movie, where you see machines are destroying the world, and thankfully this is not the scene till date. So that is what this is because of AI. The AI can do that. Okay. So now talking about then coming to machine learning. So machine learning, anybody I don't think needs much introduction now. Machine learning would be, I'll go to the next slide. Now this another slide which gives you a better, still I found these two slides to be very nice to depict this. So now see here, students, artificial intelligence is there, and then artificial intelligence, they have shown you Amazon purchase predictions, smart email categorization as a part of AI. And then moving on ahead, which is machine learning. Machine learning is putting some kind of, using some kind of techniques or algorithms for helping put intelligence into the machines. So, and this could be your supervised, unsupervised, or semi-supervised. So we will see as we progress. And then here you have Google Maps, speeds of traffic, Facebook facial recognitions, and then Netflix video recommendations. So Netflix video recommendations are there. See, the machine learning is doing this also. It will start. Netflix generates patterns and observes your, which movies you are, what kind of movies you are, interested in watching, and it will generate that for you. And Facebook facial recognition system, we all know. You put a picture of your family, and then Facebook, what it does, it tries to tag everybody. Have you noticed it? Yes, it would. This is why. This is because of the face recognition, facial recognition system of the Facebook. It is all because of that. It is doing that, and and then you have your Google Maps feeds of traffic. So then came your deep learning. Deep learning is your like your self-driving cars, your speech recognition, your speech. I think this Microsoft has come out with a claim that it has a speech recognition system where it is going to translate the exact meaning of your conversation. So which is not even possible by any other means. So we will see that. Now, artificial intelligence, just given a brief of all these one or two slides. AI is a branch of computer science concerned with making humans, making machines, making computers behave like humans, and the science and engineering of making intelligent machines, especially intelligent computer programs. And then you have AI is all about making a computer controlled robot or a software think intelligently in the similar manner the intelligent humans think. So this is about AI. And then philosophy of AI. Philosophy of AI is the philosophy of artificial intelligence attempts to answer such questions as: can a machine act intelligently? Can it solve any problems that a person would solve by thinking? Are human intelligence and intelligence the same? Is the human brain essentially a computer? And can a machine have a mind, mental state, and consciousness in the same way that a human being can? And can it feel how things are? So, this is talking about artificial intelligence. And then coming to machine intelligence. I've already touched upon machine learning. See, you have the three kinds. You have unsupervised machine learning algorithms, you have supervised, and you also have semi-supervised, or you call them as also reinforced learning. And then, unsupervised is your, what you call it as clustering, because in this what happens is the labels, it is not a guided search, it is not a guided search. You are passing the data to the system to learn on its own, to learn on its own. So it is not any kind of, the class labels here are not assigned. Okay. So machine learning kya hai? Broadly speaking, what is machine learning? It is how computers can learn or improve their performance based on the data, based on the data. So, this is three main categories. Supervised, I've told you. Supervised is, how you have classification and regression, and basically, supervision is, you're learning from the labeled examples in the training data set. In the training, for example, you have your postal code recognition problem and a set of handwritten postal code images and their corresponding machine readable translations are used as, training examples, which supervise the learning of the classification. And unsupervised, like I've told you, it's like clustering, and the learning process is that the input examples are not class labeled, and you may use clustering to discover classes within the data. So you're using clustering to discover classes within the data. And unsupervised learning can take as input a set of images of handwritten digits. For example, 10 clusters of a data. And these clusters may correspond to 10 distinct, what you say, digits of 0 to 9. And the training data are not labeled. And the labeled model cannot tell us the semantic meaning of the clusters that you generate. And then you have semi-supervised also. So this is the process they have shown. So any kind of training data is there, and then the new from this training data, you do the feature extraction thing. So feature extraction also I'll come to later. What do you mean by feature extraction? Since when we talk about the data that we have, and that is voluminous, and then the third thing is you may be and machine learning or data mining or data science talks about multi-dimensionality. You are holding the information pertaining to all the records or objects wherein they have n number of features. It's not just like databases, you have few features or variables, you name them in machine learning or statistics. So it is, you may have voluminous features, and that using all the 100 features for analysis or machine learning would not be a good thing. So you have to reduce it to a certain extent. For this, you will be using some kind of heuristic approaches or statistical methods to reduce the number of features you have, so that the number of features which are weakly relevant, or which are irrelevant, or which are inconsistent or not associated, or which do not have a strong weightage in the analysis, so can be discarded or can be removed from the analysis. So for this, you have your stepwise feature selection, stepwise, or you can take keep attributes as per the weightage they hold in the final analysis. So you can keep doing that, and you have wrapper methods for this and all those other methods also, but cannot go into much detail because of the limitation of time. And then after you have the feature, see, but for whatever n number of features that you perform machine learning, or you extraction, this should not lose the integrity. The integrity of the data should not be lost. Like it should be that whatever analysis has been done on n minus 1 number of features is as good as it would have been performed on the entire set of features. And then you have your machine learning algorithms. After you have this reduced data with you, reduced data or reduced features with you, you do the machine learning thing. And then after the machine learning, which is broadly machine learning mein hum kya kya hai, it is more of the, you have classification, you have clustering, then you have association mining, all this. And then after you do this, you are grouping, you have the grouping of the object. I mean, classification has been done. Or you have the predictive model, that your model is ready to predict. And then once you have this predictive model or the classes, then you are ready to take some new data and do prediction or classification for that. So this is what machine learning is doing for us. Okay, so this is what machine learning is doing for us. So examples I've already told you, participants. that for example, जैसे हमने Facebook का देखा, you are uploading photos to Facebook, and the service automatically it highlights the faces and suggests friends to tag. And how can it instantly identify which of your friends are there in the photo? Because it is making use of AI to recognize faces. Facebook discusses the use of artificial neural network algorithms. इसमें artificial neural network algorithms है, machine learning algorithm है, which mimic the structure of human brain to power facial recognition system. And for another example I gave you, जैसे Instagram का. Instagram, it's also by Facebook only. Instagram has been taken over by Facebook since long. And it also uses machine learning to identify what? Your contextual meaning of the emojis. आप जो emojis डालते हो, ठीक है? तो वो what it does is it tries to identify what is the contextual meaning of that emoji, which have been steadily replacing that slang, जो भी आप slang डालते हो. जैसे आपने कोई laughing emoji डाला, so then it is going to replace it by lol, laugh out loud. So this is what it's doing. So, and it is identifying the sentiments behind emojis. And Instagram can create and also suggest emojis or emoji hashtags also. And these are some of the trivial applications of AI. And Instagram has seen a massive increase in emoji use among all demographics. And it is able to interpret, analyze it to large scale, by converting the emoji to text translation. So see the beauty of it, what all they are doing, which didn't seem possible, at all. So, and you go shopping on Amazon searches, online shopping, you go to Amazon, and quickly you return a list of most relevant products related to your search. And Amazon does that to reveal what exactly how it's doing it. It is automatically there are algorithms which learn to combine multiple relevance features. So this is the beauty of it. Then your mobile use, students. Another example, very good example, is your mobile use. Mobile use. A standard feature on your smartphones is today what? Anybody can tell me? Voice to text. And you're pressing a button or saying a particular phrase like "Okay, Google," and then you start speaking whatever you want to speak, and your phone converts that audio into text. Yes or no? I'm not getting any responses. So what is nowadays? This is relatively a routine task, and Google uses all this artificial neural networks to power voice search. And Microsoft का मैंने आपको भी बताया था, it has claimed that it has developed a speech recognition system that can transcribe conversations slightly more accurately than humans even. Alexa और Echo का तो आपको पता ही है. I think Alexa is again AI powered personal assistant that accepts voice commands to create what? To do lists, order items online, set reminders, then answer questions. So all they are doing. Echo is also the same kind, smart speakers that allow you to integrate Alexa into your living room and use voice commands. You could be doing anything. You could be playing music, you could be ordering pizzas, you can be calling Uber, and then you could be integrating your home devices, you could be switching on or off your smart lights. Okay, then also example is chat box. Chat box is nothing but it is a service of artificial intelligence. ठीक है? तो वो क्या करते हैं chat box? They simulate human conversations and then interact with using chat interface. And if you are using Facebook Messenger, then text messages or Slack, then you use the chat box. Then you have used the chat box. Then coming to next slide. So again, all these things only I have shown up. Tried to actually, I was not very clear about the audience, so just gathered some information on all the buzzwords. Machine learning, told you it is supervised, unsupervised, and more of the kind I'll be showing with examples. And then this comes your deep learning. Now coming to deep learning, Deep learning is the new thing in now deep learning. It is written deep learning is a type of machine learning which model learns to what? Model learns to perform classification tasks directly from images, text, or sound, and it is usually implemented using a neural network architecture. The term deep refers to number of layers in the network, and the more the layers, the deeper the network. And they have shown you here very clearly how different machine learning is from deep learning. Initially, I told you that in machine learning, this is the example of machine learning. The feature extraction was done using definitely some statistical algorithms or certain machine learning algorithms itself. But then needed a human intervention. You were given certain inputs, and then you wanted some output. This here it shows, you're given this car as input, and probably you want to classify it as a car or not a car. And then machine learning was making use of certain feature extraction techniques with human intervention. Human setting things for, or some kind of information to be provided by human beings. And then the classification algorithm did the classification thing. It may be neural network, it could be your decision trees, it could be anything. So you could be using any decision tree, machine learning algorithm. It's not only that you're using neural networks, and then you generated an output. But in deep learning, the entire process has been taken over by the deep neural networks, the number of layers. So you simply, it is like, giving the input to it, and then you get the desired output. And there is no need for even human intervention. So deep learning archives recognition accuracy at higher levels than ever before. This helps consumer electronics meet user expectations, and it is crucial for safety critical applications like driverless cars. So this is the example, driverless cars. Recent advances in deep learning have improved to the point where deep learning outperforms humans in some tasks like classifying objects. And now coming to the next new term, which is data mining. How many of you have heard of data mining or studied data mining? Can I get a feedback? Participants, are you there?
Yes, ma'am, in chat box we are typing.
अच्छा I actually मैं देख ही नहीं पा रही हूँ chat box को तो. Yes, now I can see. Okay, thank you. Okay, so now coming to data mining. So data mining, have you studied data mining? I think this is a subject you must have studied. Yes or no? No info or yes? See, data mining students, mining is a term which is very well, आपको खुद ही नाम से ही बड़ा clear है. What is it? Mining is what? Mining is, extracting. Mining क्या होता है? जैसे हमने सुना होगा छोटे होते like sand, gold mining, coal mining. So all this is you are extracting some kind of gold from digging the earth, right? Or you do rock mining. You never call it rock mining. ठीक है, आप उसको गोल्ड माइनिंग बोलते हो क्योंकि आप रॉक्स को डिग करके कोल निकालते हो, या अर्थ को डिग करके आप गोल्ड निकालते हो या ऑयल निकालते हो, ऑयल माइनिंग करते हो. So all these, the mining word has come from that only, and this is also as good as the other things, like you are extracting what, some you are extracting some useful knowledge, some useful information, some gold nuggets from the data that you hold. The data is there with you. The data is there with every company. They are collecting with the historical perspective. They are storing the data, generating the data, storing it in the data warehouses with the time perspective, right? That it is 5 years data, it is 10 years data, it is 2 years data. But they are not putting it to some use. And mining is what? Mining is extracting some gold nuggets, some useful nuggets, some potential patterns from the data that you store in the data warehouse. It is not your operational data, mind you. It is not your operational data कि जो आप अपना databases daily use करते हो अपने operational system. It is not that kind of a data. This data has to be stored in a data warehouse. It has to be voluminous in nature, and it has to have a historical perspective. It has to be with a time constraint in it. And then you discover certain patterns which can be, or model, which can be used for some kind of analysis or some kind of decision making or some way improving your targets or a company's targets. So these are the various steps that are involved in data mining. And these steps, quickly I'll go through. You have data with you, and then this data is not just collected from a single repository. And this data has to be collected across various databases. That could be your heterogeneous databases. आपका वो spatial data हो सकता है, आपका वो temporal data हो सकता है, आपका वो flat files हो सकती हैं, आपका relational database हो सकता है, आपका object oriented database, आपका extended relational हो सकता है. So it could be any kind of data. And from therein, you collect. Okay, you make the selection process from across and you put it here. And after you have collected the data, you pre-process the data. See, pre-processing is a very vital term. Why pre-processing is very important? Because the data has been collected from across domains, across places, and that may not be consistent. The data may not be consistent. It may have missing values also. Okay, and then we need to pre-process this, and then it is collected. It has been generated wherein different units may have been used, various schemas may have been used. So we need to go with the accuracy, completeness, and consistency of the data, so that we maintain the data quality. Data quality is very important. आपका डेटा एक्यूरेट होना चाहिए, कंप्लीट होना चाहिए, कंसिस्टेंट होना चाहिए, टाइमलीनेस होनी चाहिए, उस पे हम बिलीवेबल होना चाहिए, देन इंटरप्रिटेबल होना चाहिए. So for that we need to go for some methods for pre-processing. और इन pre-processing steps बहुत सारे हैं, मेरे को लगता है अगली स्लाइड में मैंने एक्सप्लेन किया हुआ है, like data cleaning, data transformation, data reduction, then you have data reduction, and then probably the model generation. So data cleaning is very important. Data cleaning would involve removing the inconsistent data, incomplete data, and then other thing, noisy data. Noisy data क्या होता है? Anybody can answer that? Noisy data is like, the data is so dispersed, it has a lot of variance in the data. Variance बहुत ज़्यादा है data का. There are certain outliers. For example, you are generating marks of a class, and then the general pattern of the marks of the students is, let's say, it lies between 40 to 80, something like that. The students have secured 40 to 80, and then probably one student gets just a 2 marks. So this kind of a behavior, जहाँ पे 2-3 नंबर आए एक स्टूडेंट के, this is an outlier which needs to be identified and treated or removed. तो हमें इन चीजों को ध्यान रखना है कि there is no much outliers. So data cleaning is a process wherein you identify the noise. अब ये 2-3 marks is a noise in that kind of a data, because it is going to influence your mean of the data and simultaneously the grades of the entire class. Okay, so you for this pre-processing is done, and after the pre-processing, students, you have the transformation thing come in, wherein you will be applying transformation techniques. Transformation techniques like ट्रांसफॉर्मेशन टेक्निक्स में आपके पास क्या होता है? You transform the data to a uniform scale. Scaling has to be done. So all this we will see, and then you perform data reduction. I told you the weakly identified attributes have to be removed so that the analysis can be carried out. So you use principal component analysis, you do dimensionality reduction, you go for numerosity reduction, and so many things in reducing the data. Okay, so once you reduce the data, then you go ahead with data mining. So now ये भी term data mining है और यहाँ पे भी एक data mining. So this is a misnomer actually. This is a misnomer. Should have been knowledge mining or knowledge extraction or knowledge regime or something else. But data mining is just a step in the discovery to knowledge. And knowledge is what? Your patterns, your useful patterns. Okay, and once you do data mining, now data mining is again, you are making use of what? You are making use in data mining of machine learning algorithms like classification, like clustering, like outlier analysis. And then you have your deviation analysis. So all these are done, or outlier analysis, deviation analysis or outlier analysis. And then after you model that data, you come out with certain patterns. And then probably all the patterns are not useful. Maybe few may be useful. Then you have to identify which is of real use to you. And that is the true nugget, true knowledge. That is gold for you. That is knowledge for you. Okay, so this is what I had to explain here. And then coming to data analytics, again, students, data analytics is the science of analyzing raw data in order to make conclusions about that information. And data analytic techniques can reveal trends and metrics that would otherwise be lost. So data analytics is something to do with business intelligence also and business analysis also, that you need to reveal and come out with some trends and metrics which can help you in generating some kind of predictions or analysis. And this information can be used to optimize processes to increase the overall efficiency of the business or the system. And these are the steps. So I wouldn't be. And then talking about data analytics again, it could be of four kinds. I think you may be knowing it could be descriptive, it could be diagnostic, it could be predictive, and it could be prescriptive also. So descriptive is what's happening in my business, what is happening. So this is descriptive, comprehensive view, accurate and live data, and then visualization of that. And diagnostic is why is it happening, the ability to drill down, what is the cause of that, what is the root cause, and then the ability to isolate all confounding information. And then predictive is what's likely to happen, कि आपका क्या prediction है कि अब आगे क्या होगा, what would be the output, what's likely to happen. Business strategies have remained fairly consistent over time, historical patterns being used to predict specific outcomes using algorithms, and decisions are automated using algorithms and technology. And then prescriptive is what do I need to do, like your recommendation engines. Students, आपको मैंने examples बहुत सारी दे दी हैं, like your recommendation engines, actions and strategies based upon the champion, challenger testing strategy outcomes, and applying advanced analytic techniques to make specific recommendations. So this is it. And now I think the next slide talks about the data science process. Now this is the data science process, students. And from the reality, you are creating or generating the raw data. The raw data is processed. It is cleaned. Then the models and algorithms are there. And there's also one side the exploratory data analysis that takes place, and then models and algorithms. So when you're using that, you communicate by visualizing that report and then make decisions, and then that data product which is generated goes back to the reality. And then this is the life cycle. Data science is a practice of mining large data sets of raw data, both structured and unstructured, to identify patterns and extract actionable insights from them. And this is an interdisciplinary field. And the foundation of data science includes, the data science has foundation from statistics, inference, computer science, predictive analytics, machine learning algorithm and development, and new technologies to gain insight into. So all this given here. So this is again the same thing, I think. This is the entire process explained once again. This is how do you start, plan, data acquisition takes place. आपने plan किया data science में, what is the question and what type of data is needed. You start with this plan. what you intend doing, और वो डेटा आपको कहाँ से मिलेगा, from where do you generate that data, how will you collect, how will you crawl that data, how will you obtain that data, from which websites, and how much authentic it is. I told you data जो आप collect करते हो उसकी authenticity, उसकी believability, उसकी interpretability और उसका clean होना बहुत जरूरी है. Okay, so the data has been collected and this is the data acquisition thing. Data has been acquired, data acquisition is done here, and then you clean the data. Then you clean the data, and then after cleaning the data, you make data analysis. Data analysis, you explore that data, then you do feature engineering. Feature engineering, आप इसमें feature reduction भी कर रहे हो या feature enhance कर रहे हो, you are adding features or you are removing features. And then you are modeling, again would hold feature selection, models कौन से आपको यहाँ पे, again comes the role of machine learning, which models you are using, and then results are to be evaluated. And then finally you deploy and maintain and optimize. So this is the process of data science. So here you will go like this. You will start, think of what you intend doing and generate data for that. And then the data, after being acquired or data acquisition has been done, it is cleaned, and the number of steps that you go through. And after the cleaning process, the data analysis starts, and then the modeling, and then the deployment and optimization. Now coming to data acquisition, as soon as the data scientist identifies the problem she's trying to solve, she must assess what type of data is available, what might be required and currently is not collected, and is it available, is it available, is it available from other units of the company? Then, 1 minute. Is it available from other units of the company? And does she need to crawl by data from third parties? And how much data is needed? How to access that data? And is the data private, or is it legally okay to use that data? So all these questions have to be taken care of in the data acquisition stage. And data acquisition type of sources could be this: time spent on a page, data acquisition on, तो इस तरह की चीजों को हम usually we do analysis, or we do what you data science was about, collecting your website log, user and inventory data, social engagements like Yelp, Twitter, and customer support, you call logs, emails, all this. So data, these are data storage and access. You can go through this, the slides would be available. And then the major tasks in data pre-processing. Now participants comes the tasks in pre-processing. So I told you these are the major tasks in pre-processing. So pre-processing, you need to pre-process the data. That is, you need to clean the data. Data is first cleaned. Then you fill in the missing values. You smooth the noisy data. You identify or remove outliers and resolve inconsistency. So this is important. Okay, and then comes your data integration. Data integration is what? It is merging the data from multiple sources into a coherent source, coherent data source, like कोई data warehouse है हमारा. So data reduction आ जाता है उसके बाद. Data reduction, I told you, can reduce the size of the data by aggregating, by eliminating redundant features, or by clustering. And the various techniques are these: the dimensionality reduction, numerosity reduction, and data compression. So dimensionality reduction is what? Dimensionality reduction is something like, reducing the number of dimensions or variables. तो जैसे अगर हमारे पास अगर p एट्रीब्यूट्स है, तो अगर हमने उसमें से 5 में से 2 को डिस्कार्ड कर दिया, and we kept only 3, then that is called the attribute subset selection. And in case we have 4-5 attributes and we keep all 5, but use some other method like converting these 5 to only 2 principal components, which will hold the relationship that exists between these 5. So that is called some kind of principal component analysis. And techniques like wavelet transform and all these are used in dimensionality reduction or principal component analysis. And the third thing I told you, where you literally drop the irrelevant attributes, that is called your attribute subset selection. And then you have numerosity reduction. Here you may be using some kind of sampling techniques, जैसे एक population है, so from that population you draw certain random samples. So here also you may be using some kind of sampling technique. एक population में से जैसे हम sample निकालते हैं, so similarly here from set of attributes you could be using some sampling technique to draw some useful attributes, or you could be using some kind of histogram. You could be using some kind of clustering you may use for numerosity reduction. Then you may use regression techniques also in numerosity. And then data compression, string compression and all. Then after that, data transformation and discretization, wherein you apply normalization techniques or the concept hierarchy generation. Concept hierarchy generation hota hai viewing the data at multiple levels of abstraction. You are viewing the data at multiple levels of abstraction. For example, आपके पास जो information है वो आपके पास yearly sales की है. एक कोई store है, let's say any store you're talking about, and it is selling certain items and across certain locations. Okay, is this thing clear? If there is a store which is selling certain items across locations, so you want to view the yearly sales, so you can do that. Okay, so concept hierarchy generation. But in case you want to view it quarterly wise, so those aggregations quarterly wise are also available with us in the multi-dimensional view, which is the concept of a data warehouse. And then if you want to view it each month wise, you could do that also. And then if you want to view the sale of every store with respect to every item and per day sales, then you can do that. So this is the theory, concept hierarchy generation. So there are multiple levels of abstraction. You can roll up or you can drill down. Similarly for locations also. जैसे वो locations है, so if you're talking about US, you may want to view it with respect to every state wise or country wise or region wise. So all that you can do. So I told you students, this is a very vital thing, data quality, that you need to pre-process the data. You need to pre-process the data, that is the accuracy, correct or wrong, it is accurate or not. Then what is the completeness of the thing, the data is complete or not. So these all things you will keep in mind. And then consistency, the data is not inconsistent, कि कहीं पे कुछ value hold कर रहा है, कहीं पे कुछ और hold कर रहा है. And timeliness, timely updated data होना चाहिए, believable होना चाहिए, interpretable. And then data cleaning, I told you, data cleaning, data in the real world is dirty. So when the real world data hai, it is dirty. Lots of potential incorrect data. Example, instruments may be faulty, जिन्होंने data generate किया है. Some human error से हो गया, computer error से हो गया, या transmission error से हो गया. So data has to be cleaned. And this 4 types of cleaning they have mentioned here. One is when the data is incomplete, it is lacking attribute values, lacking certain attributes of interest, or containing only aggregate data. You need to identify that missing value and fill those missing value and make the data complete. And there are various methods. Then you have noisy data. Noisy data is some kind of outliers are there, some error is there, like this. Now salary minus 10 has to be an error. Okay, so you need to identify the outliers and treat those outliers using certain methods like box plots. And then inconsistent data. Inconsistent data, it's containing discrepancies in codes or names. So इस तरह का data, when age is this or birthday is this, तो ये data कहीं पे यहाँ ऐसे stored है, कहीं पे ऐसे stored है. So this will give. So I'm generally talking about I'm talking about the structured data only here. So was rating 1, 2, 3 not rating ABC? Somewhere it has been rated as ABC, somewhere it has been rated as 1, 2, 3. So these inconsistencies have to be identified. Then intentionally also, some people, like you fill in the forms sometime. Yes, you are asked to do that online or offline mode. When you go and shop on online or offline, you are asked to fill in the forms. And then you probably intentionally do that. Some information you don't want to disclose, you don't want to give your information. So you just fill in certain values. For example, they ask you for your birth date or your address. Probably you're not interested in sharing your address and you may put in anything. So the data needs to be clean. आपको consistent बनाना पड़ेगा उसको. So this all you can go through, students. How to handle the missing data? तो आप सबसे पहले मिसिंग डेटा को एक ग्लोबल कांस्टेंट से रिप्लेस कर सकते हो. Then you can use the attribute mean of that attribute. जो भी particular attribute में missing values हैं, you could replace it by the attribute mean, which may not be a best case, but to fill in certain values to give it make it more complete. So you can do that. Some people adopt this method, but depends upon the size of the data set you hold. See, because discarding the entire record for it not having one value on certain attribute will be losing certain useful information, okay, which you have for other attributes. So what do is they take up all these methods as per their requirement and feasibility and suitability. So you can use the attribute mean for a particular attribute to fill in the missing values, or they use still a smarter method of handling it would be the attribute mean of all the samples belonging to the same class. So first what they do is they group the data into different classes. For example, your class supposedly has missing value of some some students weight, let's say. So in case I go for an approach like I'll take the mean of all the students' weight and then substitute for that value, the mean value for the person who's not carrying any value on any information on weight. So that is one method, which is the second one, the attribute mean. But that was not probably the best method. When we have such smarter techniques come in nowadays, that was not the best method. So now they have gone for a smarter method, like I could be, now classifying your class into certain 10 groups based upon their height. ठीक है? तो मैंने आपका height और कोई और parameter consider करते हुए I've classified you people into different classes. And now the person who is not missing on the weight and whichever class he falls into, I will take the attribute mean of that particular class and substitute for it. And that is a smarter way of doing it. And then after this, still a better method would be the most probable value. How do you generate? It could be by using some kind of decision tree or some kind of inference based, Bayesian formula using or decision tree. So आप एक tree बनाना शुरू कर देते हो, and then you will find out where that record falls, and then you will put that value for, this is still a better method of developing a decision tree and going about. Then noisy data I've told you, random error or variance. And how do you handle it? It is by using binning. आप binning use कर सकते हो. Binning is, you can be using binning by smoothing by bin means, or using the bin medians or bin boundaries. You sort the data and partition them into bins. And then you can be using the bin means or bin median or bin boundaries. Then you can be also using regression techniques you could be using. Then smoothing by fitting the data into regression functions. So you could be using the regression functions. Then you could be using clustering. आप data को clusters में divide कर देते हो. Whichever values do not fall into any clusters, they would be treated as outliers. And then you can have combined computer and human inspection. Then detect suspicious values and check by human. That is, deal with possible outliers. And then you have data integration. Students, I told you that you have data sources with you, data source 1, 2, 3, and 4. So various data sources, and then you combine them into a data warehouse. Here you have the ETL tool, extraction, transformation, and loading. So that is extraction, transformation, and loading, which is a function of, again, it could be of the warehouse or it would be, and data integration is done. And for data integration, you need to handle redundancies. See, this is very crucial. आपको data integration करना है. I'm again repeating, I am doing it only for what? Structured data here. So for handling structured data and handling redundancy, you before going for data integration, you need to see whether the information is not redundant. That the data occur often when integration of multiple databases. Redundancy occurs when we are doing integration from multiple databases. So you need to do object identification. The same object or object, attribute or object may have different names in different databases. And second is, एक तो आपको ये identify करना है कि they are not holding different names at different databases. And second is derivable data तो नहीं है. आपका जो data है, that one attribute should not be derivable from the other attribute. It should not be. In case it is derived, then this is not the true analysis, because the two attributes in itself, we are talking about some n number of independent attributes, and wherein you have one as dependent attribute which you wish to predict. But in case you have more two attributes which in fact influence each other, or which are highly associated to each other, or which are highly correlated to each other, will not lead to a good analysis, or good data mining, or good predictable analysis. So all this has to be taken care of, and there are methods to identify, like you can go for correlation analysis. आपको सारे attributes जो आपके n attributes हैं which they are there in the which are being considered, should be independent of each other. And for that, you have your chi-square test, you have your Carl Pearson approach, which will help you in identifying that. And then, redundant attributes may be able to be detected by correlation analysis or covariance analysis. Careful integration of data from multiple sources may help avoid redundancies and inconsistencies, and improve the mining speed and quality. So this is our purpose. We have to improve the speed and the quality of the analysis, and we have to go for. So here is one method. One method for if you have a data of the nominal kind. See, there are methods for different kinds of data, and this is something to do with the nominal data. Then we use a chi-square test. And chi-square test, what does it do? For you have some observed information certainly, and then for all that observed information, you will be generating the expected outcome. And this is the formula: chi-square will be summation of observed minus expected square upon expected. And larger the chi-square value, more likely the variables are related. और ये value जो होती है आपकी chi-square, then this calculated chi-square value is mapped to a. Are you people writing something? I just check. Give me a minute. Okay, so what happens is so I was here. So what we do is calculated value जो है हमारी, अगर वो tabular value से students less है या greater than है, so we'll make an analysis whether the two attributes are highly correlated or not. So this is the beauty of chi-square, and this is very essential for finding out the independence of attributes. Initially, we start with the hypothesis that the two attributes are independent of each other. Okay, that they have no correlation, they are not correlated to each other. But then what we are trying to prove is the other way around, that we are trying to prove is the null hypothesis, alternate hypothesis. For example, they have shown you here, आपका ये है कोई एक example wherein a person is playing some chess, enjoys playing chess and does not play chess, and then enjoys reading fiction and here does not like fiction. So there were certain values for which the observations were made, and then we generated the expected. This is the expected value in brackets. We generated the expected value. Okay, so these four were the only observation. Then we have taken a row total and we have taken a column total, and then the grand total. So, applying the formula, we get this value, 507.93. And now this value is mapped to a tabular value given to us by statisticians. And based on that, we'll make an inference whether as to the two attributes, these two attributes, reading fiction and playing chess, are highly correlated or not. So similarly, we have to do for everything. Similarly, here, correlation coefficient can also be found by using small r. which is your Carl Pearson correlation. Here you have two variables A and B. You need to have their mean and standard deviations, and then you can generate small r. Small r is nothing but correlation coefficient, and the value for small r should lie between -1 and 1. And in case it is 0, that means the two are independent. But if it is towards -1 or it is towards 1, then they seem to be positively correlated. And closer the value to 1, then higher the strong or higher and stronger the correlation. So this is the formula which you can use. And this is how you visualize correlation. So if it is -1 to 1, this is how it will be. The scatter plots will look like. And this is the another formula for covariance. So this is how you will find covariance. Again, something to do with R only. RAB is equal to covariance of A and B, and you can go for expected values and generate. So you can go through all this. And then coming to exploratory analysis, then you have univariate analysis, analyze, explore variables one by one. So if it is a continuous variable, explore central tendencies and the spread of the values, summary statistics, mean, median, minimum, maximum, IQR, standard deviation. So students, when you are making exploratory analysis, and when you say it is univariate analysis, then you are talking about a single variable. Univariate means it is talking about variables one at a time, one by one. And you need to know about, what you say is, what is the mean, what is the median, what is the minimum maximum of that, what is IQR. Anybody has an idea what is IQR? Anybody? Please, anybody can answer my question. I am not going to say anything. What is IQR? IQR is your interquartile range. And this is standard deviation, variance, box plots, anybody has heard of. तो हमें ये जो central tendencies हैं किसी भी variable की, we need to know those. We also need to know what is the standard deviation of that. What is the variance? What is the quartile? The quartiles, so I'm sure you all have heard of. Quartiles are what? They are certain, regular points which are taken at regular intervals of any distribution and which divide it essentially into consecutive sets. So अगर हम 2 quantile कहते हैं, so that means there is a data point dividing it into lower half and upper half. And this happens to be, this data point is your median. And if I say you have 4 quantiles, then you have 3 data points which divide or split the data distribution into 4 equal parts, and they are called your quartiles. And similarly, if you have 100 quantiles, then they are referred to as percentile. And with the help of this theory, this IQR, and you can generate what median and all that. You will get to know कि आपके data में outliers हैं या नहीं है. आपका जो ये univariate analysis है with respect to each variable, you will be able to gather information about whether that variable has any outliers or not. So this is my purpose of telling you here. And this is the shape of the box plot that looks like. ये जो बीच वाली line है यहाँ पे, so this is the median. This is the median. And this is the IQR. ये जो box है, this is the IQR. This is the 25th percentile, and this is the 75th percentile, and this is the median, and this is the minimum value somewhere, and this is the maximum value. And these values which wo jo red dots ke sath dikhai hui hai, probably if you can see, these are the outliers. And there is a formula like 1.5 into IQR. Below the 25th and the 75th percentile would be your outliers. So any information which lies 1.5 into IQR below this or over this, then they become your outliers. So you need to make a study of the variables, univariate analysis, or you can do it by using bar graphs also. And this is your bivariate analysis. Explore relationship between variables, continuous to continuous variables. Correlation measures the strength and direction of the linear relationship. Then you visualize scatter plots. Relationships may not be linear, and you need to study those. So these are the formulas I've listed. How do you generate mean, median, mode? And this is the study about, the distribution of the mean, median, mode. Usually the mean, mode, median lies in the center. This is a normal distribution curve, and the mean, mode, median lie here. So this is called a symmetric distribution. This is called a symmetric distribution. But when it happens to be this kind of a distribution, or this kind of this is called positively skewed, and this is called negatively skewed. And positively skewed, the mode will be here. Obviously, the mode is the highest. This thing, number of times the frequency, and then you have median in the middle, and mean goes towards this side. And here, for negatively skewed, you have mean coming up first, followed by median, and then the mode would stand there. So this is negatively skewed. When there is some kind of heteroscedasticity in the data tends to be on the left hand side or on the right hand side. So, and then, measuring the dispersion, I told you quartiles are there, 25th percentile, 75th, interquartile range is Q3 minus Q1. And then you have the box plots. So outlier would be 1.5 into IQR. And standard deviation variance is explained. I'm a little fast now. And this is how the box plots look like. The 5-number summary. Box plots, they are actually the 5-number summary, the minimum, Q1, median, Q3, and maximum. And then the data is represented by a box. The end of the box are at the first and the third quartiles, and the height of the box is IQR, and the median is marked. Whiskers are the 2 lines, and then the outliers are the points that go beyond that. And then coming to the next this thing, that is the modeling. So predictive data modeling, predictive, that is the end goal of many data science adventures. Data on consumer behavior is collected to predict the future consumer behavior and to take action accordingly. Examples are recommendation engines. Netflix, Pandora, Amazon. Then you have online user behaviors to predict best targeted ads. And then you have customer purchases histories are used to determine how to price, stock, market, display future products and all. Machine learning, once again, for predictive modeling, machine learning comes into picture. Would not explain again, and will show you with an example. Machine learning tasks, these are the broadly 4 machine learning tasks. I told you clustering or supervised learning is, the predictive modeling this side, wherein you go with classification or predictive modeling, and this is unsupervised, which is clustering. You also have association rule mining. You have anomaly detection. So you could do, and here are certain examples. You are given a set of records, then and the records have attributes. Then you find a class for class attribute as a function of the values of the other attributes. And the goal is that previously unseen records should be assigned a class as accurately as possible. And a test set is used to determine the accuracy of the model. Usually the given data set is divided into training and test sets, with training set used to build the model and test set used to validate it. So this is it. And this is the example beautifully given of classification for, again, some kind of structured data. So this is structured data. So this is a beautiful example wherein they have shown you certain attributes where you have refund, marital status, taxable income, and cheat or not. So this becomes your training data. Participants, this is your training data. So any huge data set you may have with n number of attributes, these are the attributes. These are all the attributes. But here you have for a classification thing, you have a class label. Class label. So this cheat is your class label. So here you have values yes or no. So when this kind of data is given to some, this becomes a training data to some kind of a classifier algorithm. So this classifier algorithm could be your Bayesian classifier, could be decision trees, could be your support vector machines, could be your neural networks, could be your genetic algorithms, whatever. So whichever algorithm you may be using, machine learning algorithm, so will make use of this data, and based upon this class labels, it is going to generate a model. It is going to generate a model, and then for some unseen records, unseen records which do not have the class labels, or they may have a class label, but we are not going to show it here. This becomes your test data, and then we use this test data on this model and get the values for cheat. And then after we do this, we will be coming out with the accuracy of the model. See, this is a very small example. मैंने आपको सिर्फ एक glimpse दिखाया ही है. This is a very, very, very small example wherein they have just shown you that this is training data, this is test data. Okay, but usually the data is voluminous and the attributes are huge. You do all kind of feature selection on this. ये जो सारे हैं इनमें से आप irrelevant निकालते हो, पहले data clean करते हो. All that processes are done. And after that, when you get this data, you develop algorithms and then apply it on the test data and generate this value. And after you do this, then you come out with the accuracy of the model. Accuracy of the model. कि आपका ये model for this kind of data, this is the accuracy. Okay. So applications तो अब आप देखते रहना बाद में. Applications, fraud detection. I told you classification techniques are like decision trees. Then you have rule-based methods, you have memory-based methods, neural networks, naive-based, support vector machines. And this is how they have shown. Decision tree example they have shown. ये model कैसे बना? You are using one split. And this attribute is chosen with great wit and care. Okay. This attribute is chosen with great wit and care. Can you, do you know how it is chosen? Anybody? I presume somebody can answer this. How do you choose refund only? See, there are n number of trees that you can generate from a given data set. N number of trees. It's not just one tree that comes out of a data set. Anybody can answer? So, okay. So there are certain measures. See, we choose these attributes, like out of these three attributes, which attribute to choose from where we can start splitting. So this is this is generated by using Gini, entropy, information gain. So there are certain parameters which look for homogeneity in the nodes. कि कौन सा जो नोड है हम यूज करें, एट्रीब्यूट यूज करें जिससे हमारे पास होमोजीनियस नोड्स क्रिएट हों. They look for homogeneity, not heterogeneity. Or they look for heterogeneity and not homogeneity? I'm not getting any answers. So they look for a more homogeneous split. And then they start splitting. And then when they reach here, out of the left number of nodes, they again choose which has a lesser or a higher Gini or an entropy. And then they choose. And they start building a tree. And this becomes a model for this data. Okay, this becomes a model for this data. And then you can be using this. And then this is another example. We could have built it this way also. So this is the decision tree classification. So you use the decision tree algorithm and then you generated a model. And then you apply that model on this test data and generate the information for us. And start from the root node. Then this is the test data for an example. And then you check for refund. If refund is no, you go to marital status, check whether it is married, then check for cheat as no. And this is how it works. And these are the model selection and generalization under and overfitting. Probably due to the time constraint, I don't think I'll be able to move ahead now much.
Thank you very much and look forward to your continued support, ma'am. Thank you so much.
Thank you so much.